Check, can you hear me? Fine? A little loud? A little better? Too much? It's good? I could talk really loud if that's better, no?
Just because you can kind of hear it riffling off your name tag.
You know what I could do? All right. No, it's just all slides. Whoa, I see what you're saying now, huh? Don't go near there. Oh. Sure. Is it 11:30 already? All right, we'll jump right into it then. Let me just mute my phone. So thank you all for attending. My name is David Glow, and I'm going to give you a brief introduction to Cloudian. If you're not familiar with Cloudian, we are an on-prem S3 object store, right? So if you're familiar with object storage that Amazon offers, we support all the APIs, but we're an on-prem solution. So let's talk about Cloudian, right? So out of the gate, we are software defined. That means that you can deploy us in a number of ways, right? We sell appliances that come with our software pre-installed. We can be deployed as a VM. You could also deploy us on your own x86-based hardware. So there's nothing proprietary about us. Hardware consists of some spinning disks, some network ports, a couple of SSDs for the operating system, as well as Cassandra, which is our underlying technology that allows us to be geo-distributed across multiple data centers. But once again, so we are software defined, and we're scale out, right? What does that mean? That means it's a node-based approach. You have to start off with a minimum of 3 nodes to meet our minimum data protection scheme. And then from there, you could scale out. So think of it as a building block approach, right? Every time you add a node, you're not only adding additional capacity, but you're also adding additional performance because you're adding more CPU, cache, gig E ports, right? So as the cluster grows, not only does it get more efficient from a usable amount of capacity, but it also gets faster from a performance perspective. Some customers we have, as you can see, NTT, which is like the AT&T of Japan, they're over 30 petabytes today. And then Nifty, which is similar to the eBay of Japan, they have 3,500 multi-tenant users on a single hyperstore deployment. Once again, if you walk away with one thing from our presentation, we're on-prem, right? So there's no in-out charges as you would have if you were going to use Amazon's S3 service. and we're 100% native. That means that we support every one of the API calls that Amazon makes available via S3. If you have any applications today that you are using with any public cloud today that supports S3, you should be able to just point your application at us and it will work. So once again, if you look at some of the other object providers out there today, they're typically some type of gateway, right? What does that mean? They're not 100% native. They're doing some type of translation to be able to use the S3 API. And at the end of the day, that just means that your applications may or may not work, right? You could do a simple put or a get. I'm pretty sure that anybody that has an S3 connector, that will work. But if you start looking at some of the more advanced API calls, such as multi-part upload or versioning, that may or may not work depending on the vendor and if they've actually certified that it works. So two takeaways: 100% on-prem and 100% S3 native. Wonder like who's using S3 today? Variety of vendors today. Pretty much every backup vendor today has an S3 application. So it gives you the ability to do backups and then store them in the cloud. Problem there is two things, right? One is when you go into Amazon, it's great if you put data in S3, but if you ever want to access it, the charges that they typically have go up 16x when you're going to go in and out with your data. And sometimes performing a restore from a public cloud could take a lot of time. So they do have Commvault, Rubrik, Veritas, all have S3 connectors where you could tier from us, right? We partner very well with companies like Rubrik where they do instant restore, right? They do that very well, but that's also costly, right? Sometimes $1,000 to $1,200 a terabyte. So people will try and figure out, okay, I'll do 14 days of on-prem instant restore, and then they'll tier off to us so that they can free up space on their more expensive storage, still have their backups close by, right? So it's stored on us in your own data center, but it allows you to kind of have a hybrid blend of that instant restore with the ability to tier off to us. From a feature perspective, right, we have all the enterprise features that you would expect, right? So we have you could do erasure coding or replication factor at the bucket level, right? So you can determine how you want to protect your objects. We offer data compression, AES 256 encryption. So if you had any type of FIPS requirements that required your data to be encrypted, we support that for data in flight and data at rest. Multi-tenancy, we can be distributed across multiple data centers. That's what Cassandra allows us to do. If you're not familiar with Cassandra, it's one of the best peer-to-peer technologies out there today. Facebook uses it. Netflix uses it. That allows you to be geo-distributed, a single cluster across multiple data centers. If you ever try to get a movie from Netflix, you never get a sorry, come back later, this data center's down. You just automatically get routed to the closest system that has the content that you want. It's that same philosophy behind what we do. And then as I mentioned before, we could tier to pretty much any public cloud out there, GCP, S3, as well as Azure. So we could actually act as a gateway to take S3 data, convert it into a native Azure blob format, at which point then you could run your Azure APIs against that. Why does S3 matter? Because that is the de facto standard for object today, right? I think if you look at some of the Gartner reports, IDC reports, something like 96% of object data is stored in the S3 format. What that means is that you're not going to get locked into any proprietary type of protocols. Below here is a small sample of the companies that support S3. Cetera, that's kind of a remote office, allows you to have satellite offices and then store all your data in one centralized object store. Veritas actually uses Cloudian for their S3 development. They were doing things in S3 with AWS, and they found it to be quite costly. So we're actually an on-prem device that Veritas is doing their development on. And you can see a whole host of others that support S3, and the list gets longer every day, right? So let's just talk about our hardware. So as I mentioned, we could be deployed as a VM. You could purchase our software, put it on your own hardware. And then we also offer our own appliances. At the end of the day, it's a node-based approach, as I mentioned. You have CPU, you have RAM, you have spinning disk, 7,200 RPM drives that we use for our object store. Network ports, obviously, that you use to connect to your S3 endpoint. And then we use 2 mirrored SSDs for the OS and for Cassandra because it is a database, right? So that's what allows us to keep track of the metadata and understand where all the objects reside. Once again, key here is that node-based approach, so you're going to be scaling out every time you add additional capacity. From a appliance perspective, as you can see starting on the left, we have the HSA 1500 appliance. That's a 1U device that has 12 drives in it. And it comes in 4 terabytes, 8 terabytes, and 10 terabytes. So you'll be scaling in 48, 96, or 120 terabyte increments. So once again, you need to start off with 3 to meet our minimum data protection scheme. From there, you'd be adding in whatever increment you want. In the center is our HSA 4000. So that's actually a 4U chassis that has 2 nodes inside of it. And that comes in 560 and 700 terabytes, right? So what happens is that we try to scale these out, or when we try to size up your environment, if you said today, hey, I need 2 petabytes, and I'm going to be at 3 petabytes by the end of the year, we'd probably guide you to that 4000 appliance, because it's going to take less number of nodes, right, to get to that usable amount. You could also mix and match. So if you start off with our HSA 1500, say you're using the 48 terabyte nodes, you realize that your growth is starting to increase. You want to go to a more dense node, you could add in a 4000 node, and it'll migrate tokens from the less dense nodes to the more dense nodes so that more data is written to that larger capacity node. So you have the ability, there's no lock-in, you can mix and match. And then on the right there, we also partner with Lenovo. So they have a DX8200C device. So our software comes pre-installed on that. That's a 2U device, and as you can see there, you can scale from 56 to 140 terabytes. Any questions so far? No? So let's talk a little bit about how we are deployed. So as I mentioned, we utilize Cassandra, right, which is the latest best peer-to-peer technology out there. This happens to be a 6-node cluster. As you can see, they're all peers to each other. So there's no metadata controllers. There's no moving parts and pieces. You can connect to any node, and because it's running Cassandra, it understands exactly where these objects are. This could be 3 nodes in DC1, 3 nodes in DC2, or 6 nodes in a single data center. So you could deploy this in a number of ways. Another thing that's unique to us is that we can start small. You start as little as 3 nodes. You could scale to thousands of nodes. A lot of other vendors, when they offer an object store, you're starting off with as many as 7 or 9 nodes. You have to be in multiple data centers. And then when you're scaling, you have to scale in 7 or 9 nodes at a time. You're not able to just add additional capacity. And then our tagline is, we're always on. What does that mean? That means that whether you're adding new nodes, whether you're removing old hardware, whether you're doing a software upgrade, you never have to have an outage. You never have to do a reboot. When you're adding nodes, it's as simple as pressing a button, walking away. Data in the background automatically starts to get migrated. So if you had 4 nodes, you add a 5th node, data will be migrated from the 4 nodes to that 5th node so that you don't have 1 node that's empty and 4 nodes that are full. Deployment options, right? So when you see the word region, think of it as a cluster, not as a geographic area, right? So starting on the right, or on the left, single data center, single region. What that means is we have a 5-node cluster with a replication factor of 3 for an object called foo. So 3 mirrored copies, single data center, highly available, right? You could lose a drive, you could lose a node. What it doesn't help you out, though, is if you lose your data center or your WAN connection, right? Can't access your data may temporarily be unavailable. But once again, this is a way to go into the shallow end of the pool if you're looking at trying to get into object storage or on-prem object storage. In the middle here, as you can see, it's still a region, a single cluster, but it's multi-data center, single region, right? What that means is that you have 2 DCs, DC1, DC2. That could be New York, that could be LA. We happen to have a replication factor of 5, so you have the object foo replicated 3 times here, and then 2 copies are in DC2. This is where you start getting in the 9 nines of availability, right? You can lose an entire data center, lose 5 nodes. You still have access to the other 2 objects that are in your second data center. So once again, object storage is about availability, right, and low cost. So this allows you to start to expand. You could actually go beyond that to 3, 4, 5 data centers. So you can imagine the number of 9s as you add additional data centers. It continues to increase. And then on the right there, if you happen to notice, that's a multi-data center, multi-region. So think of that as region 1 and region 2, right? So those are 2 separate clusters, 2 separate data centers. This would be more if you needed to deploy a cluster and you wanted a second DR system. What would happen is that you have a replication factor of 3 in DC1. We'd enable versioning, right, which is a S3 feature. So what happens is that every time that object foo is modified, we'd keep a previous version, right? Think of it as like snapshots for objects. And all of those changes get replicated over to that second independent cluster, DC2. What doesn't get replicated over are the deletes. So if you deleted foo, you'd still have the copies in region 2. So if somebody accidentally deleted that object, you can go back to the second cluster and do a restore. So once again, that would be more if you just wanted a second cluster, right? And this one here, if you delete foo, it's going to get deleted there as well.
Are you able to configure the number of versions that it keeps, or is it only off one?
No, you could. So you could actually determine. You could just set a policy. You could say, "Hey, keep 5 versions. Start deleting it." Right. So after the 6th version comes, it's going to delete the latest. Or you could say, "Keep them forever." So it just depends how you want to do it. You could also determine where you want to lay out your data. Right. You might say, "I only want 2 objects here, and I want 3 copies there." You could also do erasure coding. Right. So you might do, in this case, it'd be a 3+2 erasure coded stripe. And then that data would then get replicated over to this second data center, right? That's real common if you're familiar with Commvault, right? When they do backups, they have this concept of primary copy and secondary copy. We eliminate the need for that secondary copy, right? So in Commvault environments, this is very popular where you have your Commvault device. It would do a erasure coded stream to DC1. We then replicate it over to DC2. And if DC1 goes down, you just redirect Commvault via DNS to DC2, and it's going to look at that second copy and think it's still the primary copy. So we give you the ability to have a highly available object store while offloading some of the tasks that Commvault or your backup vendors would do. Another common question is, if this is New York and that's LA, there's some latency that could happen, right, when you got to write these other 2 copies over to LA. So what we offer is what we call tunable consistency levels, right? So think of this as you want to define your behavior for both reads and writes as asynchronous or synchronous-like. You could do this for your metadata, right, which is relatively small in size. And then you could also do this for your object data. So if you set a consistency level of 1, that would be considered a asynchronous or eventual consistency. So in other words, as soon as the object lands on one node, your client's going to get an acknowledgement back that it's on stable storage. And then eventually, these other 4 copies would get written. If you wanted to have a synchronous-like behavior, right, strong consistency level, you'd set it to all, in which case the client isn't going to get an acknowledgement back until all 5 copies have been written. So it just depends on your workload and how you want to tune it. What some people do is they have a eventual consistency on the objects and a strong consistency on the metadata, which is relatively small in size. That way, if you have to get redirected to DC2, it'll look at the timestamp on your metadata. It'll look at the timestamp on your objects, compare them, and if they're not consistent, it'll say, hey, there's a newer copy out there. Go get it, right? So we give you the ability to tune it based off the business needs that you want, but once again, a lot of flexibility as to how it can be deployed. From, as I mentioned before, we support both erasure coding as well as replication factors. So some ways we could be deployed, right? Minimum protection scheme we offer is a replication factor of 3, right? Or 3 mirrored copies. That's kind of how Object Store originally came out. Because once again, it was all about availability. So minimum 3 nodes, minimum data protection is RF of 3. When you get to 5 nodes or more, you could do erasure coding, right? Because you could do a 3+2 erasure coding or a 4+2 erasure coded buckets. And this is all done at the bucket level. So you can have a mix and match. But once again, within a single data center, that allows you to do erasure coding. Why would you want to do erasure coding? It's going to give you a higher percentage of usable capacity. We also do replicated erasure coding. So if you remember that image in the middle, the multi-data center, single region, this happens to be 6 nodes, but you could do it with as little as 3, where you do a 2+1 erasure coded. So you write a data stream, data parity, that would then get replicated to the second data center, gives you a second copy of your data. And then lastly, for large deployments, we support a distributed erasure coding. So you need 3 data centers or more. And that's, people are going to take advantage of that when you're going across 3 data centers or more because the parity tax starts to get expensive. This gives you a higher amount of usable capacity. So this is, if you're familiar with CleverSafe, which was one of the first companies to do object storage, they do distributed erasure coding. I don't know if they can do any of these today. They may, but originally that's how they started. The problem with that, right, is you're coming out of the gate large, right? You're doing 6 nodes typically across 3 data centers. You want to go to a 4th data center, you got to add another 6 nodes. So you're typically scaling in petabyte-sized chunks. With us, it's as simple as you could add one node to each one of these. So we give you flexibility when it comes to scaling. Another thing we do, which is pretty popular, is we partner with a company called Comprise. And what they do is think of them as an HSM type of model where any type of file, whether it's a Windows box, Isilon, NetApp, Comprise can sit in the middle as a VM or as an appliance. And what it'll do is it'll scan your file environment, and you could set the policy to say, hey, anything after 60 days, migrate it over to Cloudian, right? Why would you want to do that? Cloudian typically is $100 to $200 a terabyte. Well, if you're looking at Isilon or NetApp, you could pay as much as $1,200 per terabyte, depending on what type of storage you get from them. But what this allows you to do is keep your original investment in your file environment while migrating stale data off to us to a lower tier of storage. And what happens is that when it migrates it leaves a symbolic link in place, so any applications that you have will still work, right? Remember, this is an archive tier, right? Stale data that hasn't been accessed in a while, tiered over to us. There'll be a slight delay, right? Maybe a couple milliseconds when you're going through Comprise, but at the end of the day, your applications are still going to work. If you look at some other archiving software out there, it'll leave a stub behind where you get redirected to the storage. This allows your applications to continue to work while maintaining or while archiving to a lower tier of storage. Any questions?
Is that something that you guys then would resell Comprise as part of your solution?
So today we partner with them. I think eventually we'll have it in our sales book, as our price book, so we could sell it directly. But today it's more of a, hey, we'll work with Comprise together. Comprise will do that part. If you guys are interested, we could set up our software as an OVA. They can set up theirs. So if anybody wants to do evaluations, Comprise offers a free, I think it's 60-day evaluation. But once again, it's all about saving costs, right? And I think this might be my last slide, but I like to use this because this really shows, how we could be used in, backup environments, right? That tends to be one of our more popular areas today, as we mentioned. Rubrik, Veritas, Commvault, they all have S3 connectors. So once again, when you think about S3, everybody associates it with Amazon's object store, but it's really, you got to think about it more as a protocol, right? So we are on-prem. We support all the S3 APIs. And the advantage here is two things, right? One is we're lower cost tier of storage compared to using Amazon S3. Amazon typically, I think, starts off at 3 cents per gig per month. And that's assuming you never touch your data. If you access that data frequently in and out, it can go up as much as 16x, right? So we give you that S3 object functionality on-prem, so there's no in-out charges. And we're typically about a third of the cost of Amazon. But what happens here is a couple things, right? What problems do we solve? If you look at disk-based backups with appliances such as Data Domain is great, but it's loaded with SSD. Those appliances aren't cheap. They're typically $1,200 to $1,500 a terabyte. So we can replace your primary data domain, or we could be the secondary appliance that you're replicating to. Key there is your backup servers are going to write to us as a disk target, saving you money up to 80% when you're talking about data domain type of devices. On the bottom here, right, traditional, you have a backup server, you go to tape, and then somebody takes it to Iron Mountain or something else, right? Two problems with that, right? One is, tape is a problem, right? You could do a backup to a tape, but try to do a restore, right? That could be a challenge. And, if you store it in Iron Mountain and 5 years from now, it's on AIT5 format. Do you have an AIT player? It may or may not work. You're going to be searching eBay trying to find an old tape device. So once again, we could replace all that by merely just being an on-prem disk target, right? So once again, value there is you're not writing the tape, you're not using a costly appliance, you're not going out to the internet, so you're going to be able to do faster restores. We do sales calls all day long with Rubrik because of the value we bring to them, right? Rubrik is great. Rubrik does instant restores, but there's a cost associated with that. So most people have to juggle and go, geez, do I do 14 days of on-prem backups or 30 days? What happens is that we're that tier so that when they decide to go 31st day, they'll start tiering data to us. So it's still close by for instant restores. Allows you to get that, the great technology that Rubrik sells while being able to maintain on-prem copies, right? So most people would love to do 90 or 120 days of instant restore, but there's a cost associated with this. So this allows you to balance it out and determine, how many on-prem backups you want. And that is my wrap-up slide. Any questions? No? Beer's at 3:30, I think, upstairs. So we got that going for us. All right, great. Thank you very much.